This is quite interesting in many ways. It's a work light with a focused beam, and you can actually change the focus. So if I turn this on its first mode, which is the full output power, and then I rotate this ring, almost like the lens barrel, the zoom of or focus of a SLR camera, it focuses down to quite a narrow beam, and from a distance, if you fire it at the wall, you can see it's got a sort of like Cree-like chip in it. I'd say Cree-like, it's probably not Cree. The second mode, slight shimmer here, I don't see that, it's just the camera picking it up, is the reduced intensity, and then it's got this hideous strobing mode. Plus it's got a undocumented feature that if you hold the button in for about 5 seconds or so, it goes into SOS mode, that it actually transmits sort of the Morse code. Now, this came from a UK supplier, a UK warehouse, I'd guess, because they sell sort of generic Chinese stuff. It was about £18. So it came from 2012 Pound Shop 2012, and it comes with the unit itself. It comes with 3 18650 cells, a car charger, and a wall charger, and it seems quite a good deal. Except the batteries it comes with, let me just show you this. If I pop the back off, that's not supposed to pop off with quite as much force as that, but that's okay. We can put that back in. When I pop the back off, it takes 3 of these 18650 cells. The ones it was supplied with are apparently 8,800 milliamp hour. Now, you don't get 8,800 milliamp hour 18650s. I think it's around about 3,000-ish milliamp hour is for the super high capacity ones. More typically, it's going to be 2.5 amp hour, 2,500 milliamp hour. So I tested these, and it came in at an absolutely staggering 159 milliamp hour, which is absolutely miserable. There is also a huge dent in this one, and it was so loud that I weighed it, and it came in at half the weight of a typical battery. I think this has either got air or packers inside it, so we're going to open this afterwards and take a look inside. The good news is that the unit has enough space inside to take the protected cells with a little circuit board on the end. So if you're buying one of these, I would say perhaps not. You know, don't get it with the batteries, because you're just going to get sent the cheapest, shittiest batteries they can. The chargers. This charger, I thought, well, this is going to be one of these chargers that puts out about 4.2 volts, since the batteries aren't protected. Although I've not seen inside, so I don't know if there's protection circuitry inside, so I thought it'll be somewhere like 4.2 volts, or if there is protection, it'll be a wee bit higher. So I got the meter and stuck it across the output, and the voltage is 3 volts, 3.12 volts. And I thought maybe this is faulty, maybe this unit's faulty, but if you look at it, it's got the label that says, travel charger output DC 3 volts at 500 milliamps. So it is a 3 volt output, and if this is charging these cells directly, then they won't take much of a charge at all. 3 volts is pretty much at the bottom of their charge range before they're kind of like going to cut out. Technically speaking, you want a minimum voltage of about 4.2 volts, so I don't get that. However, the greater surprise, and I hope there is protection circuitry in here, was with the car charger. Let me power my bench power supply up and let's put out 13.8 volts, which is typical what you might find in a car. So let's connect that onto there. Let's connect that onto there. The LED lights brightly. Let's get the meter back in and see what output we're getting. And I wondered, is this just going to be a universal USB type power supply? So the output of this is putting out 12.9 volts. Let's just check. That's let's see what 12.9 volts, and that's about 13.7 yet. So I thought maybe it's just because it's not loaded down. Maybe once it was loaded down it would go down. It doesn't. In fact, when I loaded it down with some LED tape, it gave me the impression there's not really much in here other than a resistor. So let's open this. Let's open this first. So these things usually unscrew at the end. Does this come out? No, it doesn't come out. No fuse. This thing usually pops off. See if it all pops out. What's inside, or is it just a faulty control circuit? Nope, it's a resistor. That's all. So, yes, it really is just fundamentally a resistor. And how's the LED configured here then? Yeah, the LED is just wired across this supply, and then it's just a resistor of a value. It's quite hard to read. A resistor of value blue, grey, black, which is 6.8 ohms. Let's double check that. And that pretty much means that if these cells don't have protection, if there's no protection in this circuitry, then you're going to potentially... Oh, actually, let's make that 6 to 8 ohms then, shall we? Or thereabouts. That's just miles off. Impressive. Okay, I was wrong. Yeah, I'm forgetting. It's not 6.8, it is 6 to 8. Clive made a dick of himself again. That's okay. I have no shame. But let's open this now and take a look inside. So, let's get this back off and see if there is any protection circuitry inside at all. Because if there's not, then connecting three 18650 cells with absolutely no protection to a charger that is coupled directly to the output, I mean, maybe it's not, maybe there is protection circuitry in here, would be a bit scary. But, you know, I have to open it first to check, to see if, you know, that is the case or not. I could be wrong. It could have protection inside. I get the feeling that it's just a standard sort of head torch type circuit board though. So let's get those screws out. Oh, one has just gone inside, that's okay. How am I going to get this out now? Oh, there we go. So there's the battery pack, there's the little circuit board. Let's pop the circuit board out now. Either way, I don't think the 3-volt power supply is going to really do much for this. So what we've got in here, it does look like there may be, possibly, protection for the chip, if that's a DW01, but I don't see a MOSFET associated with it. There are numbers on all the chips. Excuse me one moment, I'm just going to note these down. I'll be back in a moment. Hopes raised momentarily, hopes dashed completely. The way that chip was connected there, I thought it was a battery protection chip, the little 6-pin chip. It turns out it's an 819L, and it's a generic flashlight controller chip. Not much data that I could see on the internet, just because, again, it's one of these chips that we're not likely to see many applications for home use other than getting existing complete products. The 8-pin chip is a 9435P channel MOSFET, and it's then switching the light source, the Cree knockoff type chip thing, through these parallel resistors. It's positioned for 4 resistors, but they're populated with 3 1-ohm resistors in parallel to give the roughly 0.33 ohms to limit the current through the LED. So let's go a bit further. Let's take the front off this. What this means is that if you stick in this car charger thing, you're going to potentially cause catastrophic failure. So if you left this in your car and you plugged the car light or socket into this and then you went into the building site, of course the circuit board is not there, but if you plugged it in and then went into the building site or you went into the house, it would charge the batteries alright, but it would just keep charging them until they potentially failed. I'm not sure at what point a set of basic cells would fail. Having said that, these ones are so low capacity they'd probably just go pop. But if you put in larger batteries, unprotected ones, it would be a hazard. Protected ones, less so. This little 3-volt charger, though, isn't going to do a thing. It's just not going to... It will take them up from the absolute lowest charge to the point that the flashlight, the LED, went out, but it will just raise the charge in the batteries up to about 3 volts, which is just barely at their sort of bottom level. It's not going to last very long at all. It's weird. Why have they done that? Let's take the front off. It's strange. I also noted that the only point it stops drawing current is the point the LED itself goes out, which is, let's quite a nice assembly. Plastic lensing system, which is round about, oh, it's glued in, it's round about 2.5 volts, so it's going to discharge those cells pretty low, and the circuitry still remains active even though they've been discharged. Not sure if this is how it's... This is aluminium, anodized aluminium, and it's glued in. That's a bit disappointing. And the scrunchiness suggests... Oh, that's just the anodized coating. Yeah, it's scrunchy. It's very scrunchy. Am I going to be able to get that out? Oh, that'll do. This is the zooming mechanism. Okay. Oh, I see what it is. It's really just the inside the barrel is threaded, and what I was trying to force that out there, that's just basically riding in the thread with these sort of teeth at the edge, and it guides in these rails here. So that wasn't glue then, that's actually grease. Well, that explains why my fingers are all sticky. So yeah, as you rotate that, it's basically a threaded barrel that winds that forwards and backwards, and if you wind it right to the front, it then pops out. Or I could have wound it right to the back, and it's a very chunky aluminium frame. I like the chunkiness of the aluminium frame with an insert. It's got a small screw in the back here, but it's got an insert that looks as though it's screwed in to trap that LED in. I do like this mounting, that's pretty good. Yes, and of course the threaded edges to actually grip onto that and drag it backwards and forwards in whatever focal position is chosen. I guess this can go in just about any way around then. So not an awful lot in here, it's just the current limited wires, sort of silicone wires coming into this nice aluminium housing. I'm guessing the screw might just be to lock that plate here once it's been tightened up. Probably is. So really not a lot to that. I mean, it's functional. And then this, again, it's aluminium, I think, or an alloy. Then this very optically nice plastic, yeah, plastic lens. Okay, that's quite a nice aspect of it. So what does that, oh right, okay, that pinches that down onto the end of those supports, the lens, so that then as you turn it, the LED then zooms backwards and forwards inside. Okay, that's reasonable. So, synopsis. It works very well. I'd only use it with the protected batteries. I said I was going to open one of these. Let's open one of these. This is where things go really wrong. Hold on, I'm going to get my explosion containment pie dish, just in case things go thermonuclear. So let's start ripping this cell to bits and see what's inside. What could possibly go wrong? I don't think I can quite compete with Ave for ripping open huge lithium cells in a sort of, well, he saws them in half. That's a bit scary. Oh. Right. Let's peel this off. It's like playing with bombs. Yeah, what's the best way into this? Violence, I'm guessing. Is it going to go bang? Is this a good idea? I don't think this is a good idea. Excellent. I could enter by the other end. This is going to end in tears, isn't it? I'll let you know if it starts getting hot. It's always very exciting. Oh, you know what? I'm already smelling that lovely chemical smell that says that this has actually got quite a lot of air in it, but it's not got packers, and I've already violated the integrity of the cell in a dramatic manner. Exciting. It's also not really yielding its contents too easily. Don't try this at home, by the way, because, well, I mean, what am I to say, you know? Try it at home if you wish. I'm doing it. Ooh. I would go in from the other end, because it looks as though I could get the seal out, but I don't know if that... it looks so close here that I think it might be safer going. I might be completely wrong. Oh, this is just not opening. It's hard to get a grip of it because it is curvaceous. I was kind of wondering if this was going to have the packers in it. That, you know, you get the clones that it's just powder. It's basically a small cell inside a big casing. Well, this looks promising. Let me bring in my pliers for extra grip. It's very peardrop-ish. Yeah, that looks like a relatively bare cell inside. So why has it got such a low capacity? I guess maybe it's just I mean, it's very light. But it does seem to be full of stuff, unless that's just a plastic packer there. Intriguing. Am I regretting it yet? Not at all. It is proper, you know, it's solid cell in there. I think I've just probably shorted it out in a dramatic manner. But it's wound very loosely. With not much of the active material inside it. It is, you know, looking at that, it is basically full of the spiral stuff you'd expect the cell to be made of. But why is it such a low capacity? It doesn't look like they've used a large packer around it. Is it just because, I mean, it is wound so loosely inside that would also be a factor, because usually it has to be wound quite tightly for the best effect, unless it's just been made to really cheap, low standards, which would seem quite wasteful in a way. It is very smelly. It's not getting hot. That's good. Can I go any further? Is it worth going any further, or have I just proven that it's really just a shit battery because it's not really got an awful lot inside it? You know, it's so loose, it's not really what I'd call jam-packed with chemicals. Yeah, not a lot really, is there? It's a snug fit, but it is really just very loose. It's not what I'd normally expect. Normally it is a lot tighter, but you know, they filled it, but it's just so loose. It's like it's just been made it's like it's been made without quality. It's just, you know, whereas it would normally be wound really, really tight, it would be a solid core, it's just like it's been bundled up loosely and stuffed in. That's probably why it's got such a low capacity and why it's so light, because it's not so heavily compressed. But on the other hand, you'd think that to get the maximum contact area of the way they wound this, it would have been good to have that wound tightly. It's odd, strange. It's just that I'm really surprised. What I was expecting here was packers. I've got chemicals all over my finger now. That's probably not... they smell so good though. I'm surprised that it's not the usual situation that you get the small cell inside and then packers. In this instance it is completely full, so that's strange. They're just shit cells then. Bizarre. And also bizarre they put on such a hugely grossly rating. So all in all, if you buy one of these and you've got an option to get it a lot cheaper, without these shitty cells and without the charger or anything, just the bare unit that you can put your own batteries in. And if you put in protected cells that could protect against overcharge and over-discharge, then it has a potential to be quite a useful light, because it projects a good decent beam of light out. But the package that comes with the dodgy cells and the chargers is just not worth it. It's, you know, it doesn't add value to this at all. So yeah, I would say that if I was buying one of these, if you were buying one of these, do go for one that's just comes bare if you can, that you put your own batteries in. It'll probably be a lot cheaper anyway. It's also, despite the fact they're trying to make it look waterproof, I can actually see in through the gap here. The thing is not waterproof in any way, so it's more sort of, it would be quite good as a workshop light or just a general sort of area light, but not really suitable for outdoor use. But, well, as always, interesting nonetheless. Okay, a little more information. I have put gloves on just mainly to stop people going, "You get cancer." Lovely. Why is it carcinogenic chemicals always smell? So good. Don't sniff it, you'll die. But anyway, look at the inside. For a start, it does have that huge core up the middle. It's modestly densely packed, but not as tight as I'd normally expect, which is probably a factor in that. But it still contains a modest mass of the foil and the tape. And then you compare it to the size. It's a good, probably about, it's less than 3/4 the full capacity of the cell, maybe even just 2/3. But even that said, these weigh about 22 grams, and even a 1 amp hour weighs a bit, 1 amp hour cell weighs 1000 milliamp hour, weighs a bit more than these, so I'm not sure what's going with these. I don't know if they're just specifically manufactured for, for cheapness, for applications like this where they want to, well, obviously they just want to fake it. It looks like an 18650 doesn't cost as much because it doesn't contain as much material. Can I unravel this? Can I unravel this more? Yes, I can. There's the foils. It's very juicy inside. Juicy. Yeah. For those of you saying, "Oh, why didn't it just burst into flames now you've pulled all the lithium out?" It is, once again, I'll mention, this isn't lithium. These are called lithium-ion cells for a reason. It's a small quantity of lithium. The actual metallic lithium content is very low. This is a coating onto possibly an aluminium core, and it is just a surface that's receptive to lithium ions when they get transferred from one side to the other during the charging and discharging process. They're quite interesting batteries. Yeah, interesting indeed. So that's them fresh out. This is the coppery side. It looks kind of, some people say the reason it goes that sort of colour when you open it is because it's exposed to air, but having said that, it looks that colour already and I've just opened it. Interesting. Now, other notes about the flashlight. If you do use the protected cells, at 4.2 volts, because I've tried it off the bench power supply, at the full output setting, the LED is being driven with about 1.2 amps. Now, 1.2 amps minus the sort of drop across the resistors, so you're not getting that as, it's going to be 1.2 amps times roughly about 3 volts, so it's going to be 3-ish, 4-ish watts. When you put it to its lower setting, it goes down to about 300 milliamps, which means it's going to be about 1 watt at its lower setting. When the voltage in the cells has dropped down, because there's no current boosting, no voltage boosting around that, or current regulation, when it gets down to 3 volts, which is the point that the cells should be cutting off, you'll see a marked reduction in intensity, because at full brightness it will have dropped to 200 milliamps, and at the reduced brightness it will have dropped to 60 milliamps. So, yes, my opinion doesn't change in the sense that it's an interesting light. It's quite a nice light, but definitely better used with your own protected cells, the ones, the little circuit board at the end that has a protection circuitry built into the cell itself. That way you have more control over the charging as such. The charging, because you can put them in external charger, but it also protects the cells against overcharging and undercharging. Over discharging, and in those circumstances, because they can usually handle the 12 volts, something like this would work theoretically, but the 3 volt charger thing just doesn't. Odd, but there we go. It's got its applications, but it's not quite ready to go out the box as such.